All right, let's see. Can everyone hear me? I'm just curious because it says I'm live, but I want to make sure that I am. I can't even tell if anyone's joined. Has anyone joined at this point? I'm not sure. Be great to get chat's closed to attendees. Let me see if I can open that. Oh gosh. Well, I guess I will go and then I'll try to open chat. Well, I'll just give my talk and then we'll go from there, I guess. Okay, presenting, cool. All right, hello everyone. Welcome to Finding the Right Data Solution by me, Ben Rogojan, aka the Seattle Data Guy. So today we're going to be focusing on talking about, my experience kind of consulting at multiple companies, kind of helping them find the right data solutions, kind of the problems we're running into, the challenges that everyone's kind of facing, as well as just figuring out exactly, how do you kind of have that conversation of buy versus build. Just a quick background about me. My experience is in end-to-end data solutions. So I've been kind of building data frameworks, data platforms for multiple companies at this point, and helping them either migrate to new tooling or maybe update kind of their old ones, maybe have a totally greenfield approach and build an entirely new set of data infrastructure, but just helping companies at all different stages in their kind of data maturity or data kind of life cycle take a good hard look at their data infrastructure and either replace it or ask the hard questions about are they doing the right things in the first place. Also, I do tend to be an accidental writer and YouTuber, so you can find me under the Seattle Data Guy on sites like Medium and YouTube. So I've got a good amount of experience both building solutions as well as writing about it. So I like writing and creating content around solutions and tools, as well as kind of being a data engineer, because it just I think is a great chance to both reflect on my experience as well as look out into the overall current lay of the land and current map of tools that we have and figure out exactly what is going on and what maybe we should be utilizing as we kind of go forward into, I would say, kind of a third or fourth wave of kind of data tooling. So for the agenda today, what I'm going to kind of look at is some of the problems that data engineers face in their day-to-day and kind of what's changing over time, as well as some of the problems that businesses face, kind of some of the repeating patterns of work that I see, like the stuff that I keep coming in and getting called in for when it comes to consulting, and then kind of going into from there, picking the right tools and buy versus build. So that's going to be kind of the focus of this chat. It's really going to be, again, partially reflection, partially also re-looking at some of the kind of patterns that I'm seeing in terms of consulting and then trying to figure out how we can maybe improve that overall workflow in the future. So the problems that I see with data engineers is one, we're looking at a lot more data than we've had to in the past. So one, that's just the sheer amount. Obviously, again, this is the big data statement, right? Like I like to say that big data is as much of a big problem as it is a big solution. Yes, it provides more insight, but the increasing size and speed and velocity and complexity just puts more weight on data engineers to then glean, and parse and take all that information and try to create something that is usable downstream, which has also increased. I think the demand for data has massively increased. There's I think larger groups of analysts. I think analysts are becoming more skilled. And just as well as things like product managers becoming more skilled in understanding kind of data. Maybe they know some SQL, but that all just puts more weight on data engineers who are now kind of having to support the people asking questions down the line. As people have more questions, as people are trying to be more data driven, it again, in turn, just pushes the need for more data. and in turn, again, puts a lot more weight on data engineers. Also, with that comes more data sources. With SaaS products becoming more popular, I'm seeing companies in the few $1 million range have 10 to 20 data sources that they want to pull from and get information from. And, in the old days, having just set up a few kind of maybe cron jobs won't necessarily suffice anymore because you're having to manage so many more pipelines, even at a smaller scale of business. So data sources, I think, are growing, which means if you're creating custom code, you're creating a lot more custom code connectors, which in turn requires maintenance and a lot of upkeep. It requires you to have a data engineer on staff at all times, and it gets kind of expensive and just laborious on from a data engineering standpoint. Of course, with all that, with all these problems comes more data tools as people try to solve these problems. So more data tools is great, but it also, again, causes more headache sometimes for data engineers who are just trying to figure out what the best tools are and balance everything that they're trying to do, build, buy. Do they use custom code? Do they use some sort of drag and drop solution? So more data tools kind of causes problems, and then more hype articles. And I think this causes problems on both sides, both the data engineering side as well as on the management side, where you might have a manager come in, they just read an article, they now want to implement something, or as a data engineer, you read something like about DBT, and you're suddenly like, oh, do we need to be implementing DBT? Would that make our lives easier? And so finding this balance between the right tooling as well as making sure you're getting your operational work done, I think is still kind of a challenge. And just kind of looking at that, I think data engineers kind of remain the main bottleneck. When you look at kind of our work cycle, we tend to be where everyone comes to for creating new data sets. And because I like to always say, like every new data set you create ends up creating, 2 or 3 more tasks in the future because, someone changes how an API works. Someone changes what columns exist in that table. And now someone wants to add new columns. Maybe you're now having to juggle dealing with something that's broken. There's just a lot of different kinds of problems that occur because you created one new pipeline. So that all just adds a lot of weight just on the operational side. And then, of course, you're still trying to bring in new data sets. You're trying to optimize old workflows. You're trying to take data scientists' workflows and productionize it. There's just a lot that we're juggling and a lot that comes, I think, our way where we have to kind of work on that and build all that. So I think that's a lot of the extra weight. So the problems that businesses face, right? Like on the flip side, right? Like, okay, we've got data engineers; they're dealing with plenty of problems on their side, and now we can kind of flip onto the business side and kind of what all this leads to. What's the actual impact? And I'd say one, there's still kind of a lack of a source of truth. I say that because I feel like I still hear products that tout the fact that they will help a company get to a source of truth, but I've heard that at least for nearly the last decade, and we're still kind of on this point where it's like, how do we create a source of truth? I think it's become more difficult as things are better integrated, right? Like you've got your Salesforce that's integrated with SAP, it's integrated with Workday, and now you've got job level or job title in 8 different places. So even doing things like pulling basic employee information, if not done well, can cause some sort of down the line impact in terms of quality of data, or at least quality in terms of like syncing of data. And I think this is, again, just going to be a continual problem that grows. And it's not a problem that's often solved by tools alone, but a problem that's solved by a combination of tools and processes and standards. Also, again, poor data quality remains. I've definitely seen even data quality problems that don't even have to do with like missing data. I've seen duplicate data go into reporting. I've seen innocuous numbers kind of going through reporting, bad kind of data because maybe an analyst built a dashboard that had tons of extra logic on it, and then one change broke the entire thing. So poor data quality, I think, is still a major problem that occurs, and we're still trying to figure out, and it obviously impacts the business. Also with that comes slow data pipelines and dashboards. I'm still seeing at the very least slow dashboards. I've seen companies have, waiting times of 5 or 10 minutes for a dashboard, which, I think we're hopefully past that when you develop either configurations that work better in terms of like maybe how you're clustering or indexing, depending on the data warehouse solution you're using, or how you're, maybe pre-aggregating or slicing the data or partitioning it in such a way that, you're not having to query all the data in one kind of foul swoop. Another kind of major problem is just a lack of clear data goals and strategy. I've definitely come into many projects where I'm called in and asked to uh, build something, whether it's pipelines or data warehouses, but there's not kind of an end data goal. Yes, you want me to build this pipeline, but what are you going to do with it? What decisions is that going to drive? Where is it going? I think initially it's fine to kind of start with just trying to pull as much data as possible. But after you've kind of set up your first month or two portion of a project, I think it's good to have some sort of deliverable, like a dashboard or something that just helps people see one where you're at, and two kind of just have some little tidbit of where you're going to start trying to use this data in a strategy format. Because eventually, when you do have all that data, if you don't already have kind of a process in how you utilize it for higher level decisions, it's going to be difficult to implement. Also, just a lack of data engineering standards, I think, is kind of a continual problem. What is the right tool? What is the right way to build pipelines? Where does the logic live? I think is still something I see done in every which way, which causes problems, especially if it's at the same company. Data engineers are expensive. It's definitely a role that's becoming, above six figures in most U.S. states. So it's very hard to have one on time or having one full time all the time, depending on how big your company is, or maybe having a large team. So I've seen that kind of cause problems as well, because maybe people try to utilize software engineering instead to kind of maybe not have to hire a full person, but instead maybe just have a software engineer use 20% of their time to build data pipelines. And then skill mismatches, which is just because of the complexity and broadness of tools. Yeah. So next, I'm just going to talk about some of the things that I'm seeing in terms of constant kind of patterns. I'd say just like the things that I get called in a lot for, and they're very consistent. So that's why I think it's interesting. So and I think it also kind of shows where maybe you are in terms of like data maturity as a company. For example, engineering is managing pipelines. I mentioned that earlier. Maybe you've got software engineers managing your pipelines, which I think makes sense early on. If your company, is a startup, you want to do some analytics, but you don't have, a huge budget. So you can't afford to invest in a full-time data engineer. That does make sense. I can totally understand that. But then I think at a certain point you eventually grow, and you need to start considering, hiring on a staff and kind of moving over a lot of that workflow and a lot of that workload onto a data team. Hiring an analyst, hiring a data engineer, things of that nature. And so I think I've seen a lot of situations where that's where I've come in, is that engineering has managed those pipelines, and now we need to switch them over. Another one is pipeline. Maybe someone developed these pipelines and now they've quit. So you had one really smart DE, or maybe a team of really smart DEs, and they all have quit within a 3 to 6 month period. And maybe for a while, those pipelines continued to run because they were smart. They created solid pipelines. But after 2 years, they're starting to break. I had a lot of that happen this year because of Python 2 and Python 3. That whole kind of switch over, people just had a lot of things end up breaking as other Python libraries started trying to update and no longer be compatible with Python 2, at least in their kind of updated versions. So that was a problem, as people kind of had a lot of little breaks here and there. Custom coded solutions, I always like to say people end up just rebuilding Airflow in most custom coded solutions. You need a scheduler, you often need a metadatabase, you'll end up building something to manage dependencies, and it just ends up looking a lot like Airflow to some degree. Maybe you didn't have as many people working on it, so it's not as full, but it just has some similar feel to it. So custom code solutions, I feel like there are still reasons to maybe build them here and there when you have more complex policies and maybe infrastructure setups where you're having to deal with a lot of on-premises, and maybe you can't directly connect to certain data sources because of, again, regulatory reasonings, which I've dealt with. But overall, I think custom code solutions, 100% custom code solutions, personally need to be on their way out, just because it is so expensive to manage and there are so many data sources we need to deal with, that 100% custom coded can be very, very hard to maintain, as much as they're very fast to build early. That's the other reason I would say like custom code's fine, is like if you've got like 3 pipelines, that only run once a day, and you're running it on cron with bash or python, it's fine. But once you start getting into that, we're dealing with 10, 20 pipelines, multiple data sources, you're starting to need to start considering, maybe something more like an Airflow or something that's already kind of developed, and you're just implementing it in order to try to manage all of the complexity of your data pipelines. And then finally, slow dashboards. I still see a lot of slow dashboards out there where queries are running 15 minutes sometimes just for users to wait, often because you're developing some sort of single layer data warehouse where you're just loading the data into Snowflake, and then maybe at best trying to just run it as a large and being like, well, that's fixed the problem until you look at your Snowflake bill and realize you're spending way too much. And I think there are ways around that as well. Again, this does depend on your goals with that dashboard. Is it running every day? How often is it running? And that's a longer term conversation. But slow dashboards I still see kind of existing here and there, and that's another reason I've seen in terms of like constant patterns that I've been called in. I just kind of I like this slide in general just because I feel like I think it also describes some just current situations in terms of data pipelines, which is there's like spaghetti pipelines that still exist out there. They're kind of built up of just about everything: Python, PowerShell, Bash. They're all running on cron. They're kind of set apart with, like this pipeline takes 10 minutes to run. So I'll set the next step to run 20 minutes from now, and trying to just cobble together systems. Again, this is fine when you start, but as you get more complex and you add in more data sources, I don't think this becomes manageable. You basically have to, again, rebuild Airflow whenever you're building this, or develop some sort of crazy mishmash that will just be really hard to maintain in the long term. And I don't think it's often worth it after a certain point. I think after a certain point, you need to look at what solutions exist out there, whether it's build or buy. You've got plenty of solutions that exist that can help simplify a lot of this process, and will just hopefully be more maintainable in the future. I think that's the big thing. You might be spending a little more upfront for some of these licensings, or maybe for finding the right person that maybe again understands something like Dagster or Airflow. But in the end, those solutions can be a little more maintainable in the long term. So what now? Again, I've kind of talked about problems, a lot of the problems that I see. Again, they seem to be on repeat for me. I seem to be seeing the same thing over and over again. But where do we go from here, right? Like, it's easy to call out these problems, but what is the plan in terms of long term? How do we go get away from this kind of trap of like custom coded solutions and engineering managing pipelines and things like that? What's kind of the long term, and what do I usually kind of approach in terms of like setting up data infrastructure? Okay, usually what I see when I first kind of bring this problem to people, or they're bringing these problems to me, is they're usually having first conversations about like, do we buy, do we build, do we use open source solutions? And these are the kind of three mindsets that I see people have in terms of conversations. But I think this is often premature, because we really need to say, like, well, let's set up your data strategy first. Like, what is your goal? Whenever I start working with companies, the first question is more about like, what's your goal? What are your data sources? How often do you need data? Do you have reports that you're trying to currently create? Do you have specific QBRs and things of that nature that we need to develop? Do you have specific KPIs? And trying to understand kind of the scope of their data strategy and kind of where they're trying to go with all of this, and their data infrastructure. So you're really trying to scope out everything that you currently have and you're currently managing. Then you can start looking at solutions, right? Because you've now kind of set up the problem, right? You kind of understand the problem. You understand what data source you have to deal with. You have to understand what your maybe SLA type things are. Like, you want reports done monthly, daily, weekly, etc. You have the specific KPIs you want to create. Now you can start looking at solutions because you know what tools to use, right? You know, if you have a screw or a nail, if you're trying to build a house or if you're trying to build a barn, you've kind of defined this a little more. And so now we can go to the next part, which is data solutions. And you can start asking yourself the question of, do we build? Do we buy? Do we use open source? So that's where you can kind of go to next, right? Like, okay, now you can have this discussion: buy, build, open source. Well, what makes sense? And then from there, you can do solution implementation. Obviously, that's execution, just making sure you implement it well, use good standards, things of that nature. And so that's obviously a very high level skip of all this. But like, again, I think a lot of people maybe skip the first part. And again, they read an article about Snowflake and how great it was, how fast it was, how usable it was, whatever it is that really brought you to it. And then you're on that solution, but you didn't really fully assess why you needed it in the first place. And these are kind of the three areas I usually like to focus on first. I say three because the fourth is kind of, again, that last bells and whistles: data ingestion, data storage, and data viz. Only because you get these three down right. There are obviously other steps, but if you get these three down right, then it becomes much easier, I think, to add all those bells and whistles, all of the reverse ETLs and ML and all the other fancy stuff you're trying to do. Again, starting out with data ingestion, you just need to start. How are you going to pull all this data? Sure, you need to figure out where you're going to store it, but if you don't know how you're going to pull it, that kind of also plays a role into data storage. Um, and I also included data viz. Actually, I realized I should have put data viz at 3 versus 2, but I also included data viz because I think a lot of people end up building a lot of these solutions, and then they don't really know where it's going to go and what it's going to do. So, right, you've created the pipelines, you've created this data storage. Well, where are you going to use it? What's the plan? So, making sure that you include data viz in your kind of three-part discussion early on with tooling, I think makes sense, because that's going to change maybe some of how you store the data. Maybe not necessarily the tool, but how you actually create and store and architect that data underneath. So that's why I do think data viz is important. I also think that data viz drives a lot of the strategy in terms of, like, if you know what you're trying to look at the end of the day, even if it's not the direct dashboard, if it's at least the KPIs and metrics. That's going to drive what data you should be pulling in first, or what data you need to prioritize. Otherwise, it's really hard to kind of get a grasp of, like, well, where do I even start? Well, are you trying to do employee reporting? Are you trying to do customer reporting? Are you trying to then from there do customer reporting on the app? Are you trying to do it on marketing? Where are we focusing? And that's going to drive a lot. So if you're just doing data ingestion and data storage, you're just going to try to ingest everything all at once, and it's going to be very expensive and very fruitless at the end. Right? You're going to build this big tree and it's not going to produce anything because you haven't actually thought about what you want to produce. So I think it's important to, maybe early on start playing around and pulling in data. But as time goes on, somewhere in that first few months, you need to start defining exactly what you're going to do with this data, for multiple reasons. One, it helps the data team, and two, it helps the business see the value. If you don't have some sort of deliverable, within a short period of time, I think oftentimes business gets a little worried that they're pulling in all this data. They're spending tons of money on Snowflake. They're spending tons of money on consultants. They're spending tons of money on, data engineers and data analysts, and nothing's getting done. So that's why, again, data viz I think is great, because it's just something tangible that people can see and then attribute to some value. Hopefully, it does provide the value, but at the very least, again, if you're trying to get those that buy-in and more, people to continue to support a project, I think having tangible deliverables is important. And data tables are not necessarily tangible deliverables to business people. It might be to technical people, but I don't feel like it is to business. From there, again, you can focus on all the bells and whistles. Once you've got a solid process to get those first three areas focused on, bells and whistles will come. Like all the fancy stuff that you want to do, ML, reverse ETLs, etc. You'll get there. But step one starts with just solidifying those first three areas. Okay, what to consider when you're picking tools? You've got your data problem. You kind of know what it is. You set up your data strategy. Now you can start thinking about one, long-term strategy, because that's going to drive your goals. Like, how much data are you planning to store? Is it going to be streaming data? Things of that nature, because that's going to change cost a lot, depending on the tool that you're using. Especially if you're using something like Fivetran or something similar that charges by maybe rows or something. It's going to get very expensive if you start streaming it. But it just also depends. Your team size, if you've got 2 data engineers and you've got 100 data sources, you're going to want to use a low code solution. Like, again, Rivery, Fivetran, Matillion, something that tries to take away a lot of that heavy lift, because, they're going to need that support, and you want them to have weekends. Your team skill set, oftentimes I find that teams are either very code heavy or very tool heavy. There's always some cross in between, but I think in general, some teams just prefer one or the other, and you can kind of mix it up too, depending on if you've got a good mix or a hybrid team. But just assess your team skill set, and don't set them up on Azure Data Factory if they're all a bunch of I don't know, Matillion developers or MicroStrategy or something of that nature. But make sure you're picking tools that work for your team, or make sure to plan for a lot of upskilling and for there to be a learning curve. Your budget, of course, comes into play. There's a lot that money can solve in terms of problems. You can hire consultants to fix problems. You can hire better tools. So budget also plays a role. And then your data maturity. Where are you in the path? Again, if you're a 3-person team, 3-person startup, you need some basic ETL. Using Bash scripts or Python scripts because you just need 2 data pipelines is not the end of the world. It's probably a good choice rather than investing in a heavy amount of infrastructure. But on the flip side, if your team is now, your company is 100 people and you've got 30 data sources and, you're still trying to use a lot of custom code, it's going to become very expensive down the line. You're going to have migrations that are going to have to occur because you're doing so much custom code, like a Python 2 to Python 3 migration or something similar. So there's just a lot of expensive steps as you process in your data maturity. So I think that's a very important thing as you try to just get down that line. All right. So the buy versus build. Obviously, I think some of this stuff most of us might be familiar with, but buy versus build. Buy is great because it can be fast, right? Like in theory, if you've got a lot of systems that are very well utilized, like Workday or Greenhouse for your HR system, you can use something like a Fivetran or a Rivery or an Airbyte or something that has a connector to it already, and automatically start pulling data in that day, rather than custom coding an API connector that's going to take 2-3 days to develop and test and make sure it's pulling in correctly. So it's fast, obviously. Not very flexible. A lot of these tools have some sort of limitations where either you can't code things, or maybe you can only select certain times to rerun. Maybe you can't scale, right? Like there's some limitations in distributed computing sometimes. So that's often a limitation in tooling. Vendor lock-in, obviously, if you sign a contract, especially if it's a multi-year contract, that's going to lock you in. Also, just utilizing the tool is going to lock you in a little bit, and that's going to get that's going to be possibly expensive in the future, which leads us to the next point, which is it can be expensive. Of course, uh, tools are great, but you're paying for often some sort of reduction in overall employee, right? Like often these tools are meant to, instead of needing 10 employees, you hopefully need 5. And so that's why, depending on your team, depending on your goals, depending on everything, tools could be cheaper, but they could also be more expensive if your company is newer and you're signing a $50,000 Looker contract, but you only have 10 people, and maybe Looker is not the best solution because you're only, bringing in $500,000 a year. So that's always an important question. But in theory, also, buy brings less maintenance. In theory, right? Like in theory, it should just be running and operating, and then hopefully the company that's built the product is going to maintain it. And then build. Build tends to obviously be slower, but more flexible, right? Like if you have something you want to add in, and it's code, it doesn't take much to do in terms of, like, you're not having to finagle with anything. You don't have to reach out to support to fix something, but it's obviously a slower process because you've got to code it all from scratch. And even slower there, it's probably slower for bigger projects. I think it's pretty fast to do some small projects sometimes if you're just spinning something up in cron. You still do have, I feel like, lock-in. Like if you're building something in Airflow, and then you want to switch it over to Fivetran or something else to be your orchestration style tool or something, you still have time to switch. Like there's still going to be costs there. So you still have product lock-in. You don't have necessarily a contract, but you still will need to, like, if you want to switch to, like, from one orchestration tool to another, from one engine to another, it's going to be expensive and time consuming. It obviously also can be expensive here too, because building requires a lot of expertise. Contractors are expensive, employees are expensive. All of it tends to be expensive, and then you have the required maintenance costs that can add up. So in theory, obviously, the best solution is going to be what works for your company based off your skill sets, your long-term goals, what tools and SaaS products you're already utilizing. Because if you're utilizing a lot that have easy connectors to third parties, I think then it works great to use that, as long as, again, you're at the scale that it makes sense. But if you're doing a lot of custom solutions anyways, maybe it makes more sense to use something that's actual code. So that's kind of those two sides. So just my key takeaways from this overall conversation. Data engineering and management is getting harder, but tools are getting better. I always like to use the example that we've gone from thinking about bytes and bits, right? Like if you used to be a DBA, like back when people had things on-prem, you only had so much space on the server, so you were literally caring about how many bytes a column would take, if it was a username or something. But now we're caring about gigabytes and terabytes, and like how much are we processing in one query. So it's a bigger problem. It's expensive. and we're also dealing with just more data sources, more complexity. We're trying to get a better, we're just trying to get better insights into our overall company, right? Like we want to get even deeper into customers, right? Like IoT devices and figuring out exactly how customers are utilizing our devices, right? Before you used to just sell a workout bike. Now you can tell exactly when someone's working out, what video they watched when they worked out, how fast they pump the pedals and things of that nature. And that all that data is great because you can make great decisions on it, but it also creates a lot of extra lift. So things are getting harder, and hopefully tools get better and we can start, moving away from that. Also, before you start looking for tools, make sure you plan out what you're actually trying to do. There's plenty of tools, and sales engineers are great. And as our AE or sales people, they'll always tell you that their solution is the best, which is in some cases correct. But if you don't have a framework for what you're trying to get, you'll just fit into whatever sales pitch that's provided. So making sure that you understand your problem, so that way, one, whoever's trying to work with you, the partners are going to find the best solution, and two, that way you kind of have a good definition of success at the end of this project, is important before going out to tools. And of course, you should always consider your company's limitations and strengths. Not all companies have a 10,000 person engineering team who can custom build everything and support it afterwards. If your company does not have that support, you should consider possibly either tools or just solutions that maybe try to get rid of, like DevOps, like Astronomer.io or Cloud Composer, just anything that tries to take away a lot of that lift. So yeah, that's kind of been my kind of gleaning from this year, what I've kind of picked up on, as I've kind of worked through everything. So yeah, that's kind of my overall talk. Now I'm trying to figure out. I think I can actually see Q&A. So if anyone has any questions, I would love to talk more. I think I went a few minutes over. I think I'm supposed to end at 12:30. But if anyone has any questions, I'd be happy to talk and provide any extra information that. Mhm. I don't see any questions at this moment. Um, I do hope that was helpful in terms of, like, I don't know, giving some perspective in terms of like the problems you run into. Again, as you try to engineer data solutions, there's just a lot of options out there in terms of tooling, but there's also, I think, a lot of repetitive problems. Again, you've got engineering trying to manage data pipelines, and I think that should be more in the data space. You've got single layer data warehouses that are very expensive to manage. If you're running hundreds of billions of rows and connecting it directly to Tableau or Power BI or Looker. Sure, you can turn it up to a large if you're using Snowflake, or try to utilize compute versus maybe trying to engineer data better. But it's going to get very expensive. I also think custom code solutions are great. I have fun building them, but I think we are at a point where it's the requirements that come with all the data we want are starting to push against that, and we need to start making, I think, considerations on what can we use custom code for. Like there's things that will always, I think, need to be utilized more from a custom standpoint, but what can we start lifting away from data engineers so that they can focus more on things like data quality, data governance, and things that are really important in order to actually have accurate reporting. So if no one has any questions, I will kind of end this broadcast, and I thank you all for your time, and I will see you guys next time if you happen to jump on my YouTube channel. Bye.